HTTPS is a sealed envelope, and HTTP is a postcard. With HTTP, anyone on the network can read what you send. Passwords, cookies, credit cards, numbers, anything, everything is in plain text. HTTPS, on the other hand, seals that envelope for you. Only the recipient can open it. In this video, you will learn what TLS actually does, how the handshake works step by step, why certificates matter in your workflow as you deploy your applications, and where TLS shows up in your DevOps work. I am Dara, I'm a DevOps engineer and a creator. Let's go ahead and break this down for you. Every modern browser flags HTTP sites that it's not secure. Google ranks HTTPS sites better. Users, they leave HTTP sites way faster. Even in 2026, who actually still does raw HTTP? I don't know, but if you do, this video is probably for you. And if you want to know why, this video is also for you. But this is not just a user experience thing. It is a security baseline. Without TLS, attackers on the same network can read your traffic. They can even also modify that traffic. They can inject scripts, steal your sessions. HTTPS in this case will solve three main problems. Confidentiality. No one else can read your message or your traffic. Integrity. Nobody can tamper with your traffic and your data. And authenticity. You are talking to the real server. When you visit a site, your browser does what we call a TLS handshake. When you visit a site, your browser does what we call a TLS handshake before any real data flows. It happens in milliseconds, but a lot is actually going on behind the scenes. Step one is client hello. Your browser says hello to the server. It sends a list of supported cipher suites and TLS versions. Think of it as, here is what I can speak. Are you there? Can you hear me? And the server says hello back. The server picks up the cipher suite. It sends back a certificate. The certificate proves that the server is who it claims to be. And then the certificate is verified. Your browser checks the certificate against a trusted certificate authority. If it does not check out, you get that scary red warning. Depending on how your browser says it, it's gonna probably be red or plain black with some buttons or things you cannot click anymore. And step 4 is the key exchange. The client and the server agree on a session key using what we call an asymmetric crypto. This is the actual magic, if you want to call it that. They can agree on a secret without ever sending it. And then your connection becomes encrypted from that point on. All traffic is encrypted using the agreed session key. So what exactly is a certificate in that case? A TLS certificate is simply a signed document. It says, this server owns this domain. It contains 1, the domain name, the server public key, the signing authority, and the expiry date when that agreement ends. So what happens essentially is that certificate authorities, they sign this. Your browser trusts the list of those certificate authorities. By default, Let's Encrypt, DigiCert, Sectigo, and just a whole lot more of them, but those are the 3 very common ones we hear these days. If the certificate is signed by a trusted CA, your browser would accept that connection and you just go through without any warnings and any glitches. If it expired, you get a warning. If the domain does not match, you also get a warning. If the signer is not trusted, you get a warning. Warnings everywhere, or maybe even blank red all over the place. This is why self-signed certificate errors. This is why you see self-signed certificate errors in dev environments. One IP address can host thousands of HTTPS sites. How does the server know which certificates to serve per site? It's called an SNI, server name indication. The client tells the server which domain it wants, and as part of that, TLS hello says all that in that process. Without SNI, shared hosting at scale would never work. This matters for you because modern load balancers like Azure Application Gateway uses SNI to route traffic to a whole load of services, hundreds, maybe even thousands. Then there's the concept of HTTP 2 and HTTP 3. HTTPS is not just about encryption. it unlocks newer protocol, or it unlocked newer protocols. In HTTP 2, there's a single connection, header compression, faster page loads. When we go to the world of HTTP 3, it runs over quick, QUIC, instead of TCP. There's a faster handshake, it's better on flaky networks, and it has a mandatory TLS 1.3. Both of them, HTTP 2 and 3, require TLS. If you're still using HTTP 1, you are leaving performance on the table, literally. But then, what is manual TLS? It's just normal TLS. The server proves who it is. The client says anonymous, and that's it. But then there's mutual TLS. Both sides prove who they are. The client would also provide a certificate. And this is why this matters for DevOps, especially in service mesh authentication. Istio, LinkNerd, both use MTLS by default. Zero trust networks. Every service authenticates every call. API security in regulated industries, financial services, healthcare, MTLS is the bar. But then it's not all rosy. You would eat problems. There are common problems you eat with TLS, with HTTPS. Expired SAT, that's classic. What do? You set up monitoring. Let's encrypt. If you use that, it auto-renews for you. Mismatched domains. Certificates for domain example.com uses www.example.com without a SAN entry. That is also a common problem. There's also the problem of a mixed content. HTTPS pages loading HTTP assets. The browsers will block this in this age and time. Weak cipher suits, OTLS 1.0 or 1.1 still enabled. Hey guy, what are you doing? Upgrade it now. We also have the problem of certificate chain issues. Server not sending immediate certificates. It works in your browser, fails on call on the load balancer. That is also a common problem. And this is how this shows up for you as a DevOps engineer today. You will see TLS everywhere. Load balancers, API gateways, Kubernetes ingress, cert-managers, everything. You even see it in service mesh. You see it in your database connections. What you need to do is that you need to know the handshake, know the failure models. You will debug TLS issues for the rest of your careers if you don't. HTTPS is table stakes. Before TLS goes way beyond browsers, it is in your load balancers, it is in your service mesh, it is in your zero trust strategy. Know how the handshake works and know where it breaks. Drop a comment. What is the weirdest TLS issues you have shipped or faced ever? Well, mine was missing an intermediate certificate that failed only on Android. Well, not in my current job anyway, that was way long time ago. I'll put a link in the description for a DevOps roadmap if you're just starting out in your DevOps career, and I guess I'll see you again in the next video. Stay safe and goodbye. Hey, before you go. Subscribe if you have not done so, and like this video. I'll see you. Yes, I'm gone now. Bye.